And they are binary, oxyacids. Don't get cute out of that. People start weird conspiracy theories there. Oxyacids and organic acids. Binary acids, the word binary, when you hear the word binary, what do you think of? Most people think of the number 2. And so binary acids have 2 elements only. Now you can have 2, you can have more than one of a particular element, like let's say water. Water is considered a binary acid. It's an acid because it starts with hydrogen. That's a good way to look at it here. Most acids, not all acids, but most acids in the name or the formula of the compound begins with a hydrogen. And so this can be considered an acid. Another one is HF. So it has one of each element. There's 2 elements though. We have 2 elements here. We have 2 hydrogens and 1 oxygen, but it's still considered binary. And we have H2S. So they have a specific naming system just for binary acids. And for each of them, they all begin with hydro. Now I know water's not called this, but technically it could be. And so we'll just kind of play that game. This one starts with hydro. Oh my goodness, I don't do that yet. So let's finish this. It's hydro, and then it has oxygen in it, so we call it hydroxyic acid. Nobody uses that term, but it could be called it. It could also be called hydrogen hydroxide for the same reason that we showed when it broke down. No one ever uses that either. In fact, I knew somebody who gave a speech on hydrogen hydroxide, the dangers that many people were dying because of that, and it wasn't because it was toxic, because they were drowning in it. But very funny speech. I thought it was pretty good. This one begins with hydro because it's a binary acid. All binary acids begin with hydro. And then this is fluorine. And fluorine is a halogen. All the halogens end with INE. So you simply drop it and put IC acid. So this is hydrofluoric acid. So we drop the INE and put IC acid. And all the halogens will do this. They all end with ic acid. And they all begin with hydro, as long as they only have 2 elements in the compound. H2S is a little different. This is sulfur. This is a binary acid, so we do begin with hydro for this. But in this case, I put sulfuric. It's sulfur. It is sulfur, but then we add the IC acid to it. This is all one word, hydrosulfuric acid. Okay? If we had PH3, which is H3P, if you want to write it like that as an acid, this could technically be called hydrophosphoric acid. But again, if it was called that, that would be how you would name it, but that's not really the name that people use for it. But technically it could be, but because it's not acidic. And in fact, well actually it is, because this is what we call a Lewis acid. But they don't call it hydrophosphoric acid, they just call it phosphorus trihydride. There's other names for it too, which is escaping me right now. So we'll pretend like I know what I'm talking about. Move on. Now, the next one are oxyacids. Now, oxyacids have 3 elements in them. Hydrogen, oxygen, and one more. And the one more is usually, but not always, usually a nonmetal, but it doesn't have to be a nonmetal. Examples. We have HNO3. Hydrogen, oxygen, nitrogen. 3 elements, but also it's an oxyacid obviously because of the oxygen in this. But how do you name it? Well, it's not a binary, so it doesn't begin with hydro. So if you put hydro on these in your practice problems, that is incorrect. Don't do that. That's a no-no. What we have to do is look at the polyatomic ion charge that contains the ion that does not have the hydrogen and find that. So you go to the polyatomic ion chart, it is NO3 negative. Now it's negative because you removed an H positive, making this negative because the two have to add up to 0. You look at the name for that, and this is called the nitrate ion. We'll just put nitrate on. This is nitrate. And here's where the naming system kicks into gear. We drop the ATE for this and put ic acid, just like we did with the INE. In fact, there's some acids that actually do the same. It's not classified as either one. It kind of has its own category, and they all end with ic acid. So we'll deal with that very quickly at the end. But this is nitric acid. Because it's an acid, it has to begin with hydrogen. It's an oxyacid, so it means it has oxygen, and it comes from the nitrate ion, which gives it the name nitric acid. Now, not all ions on the polyatomic ion chart end in ATE. Some of them end in ITE. That's where we get H2SO3. H2SO3 comes from SO3, 2 negative. You take a look at SO3, you go to the polyatomic ion chart, you find that it has a negative charge. That's why we have 2 hydrogens here, because they have to add up to 0. The charge is not so important for this as it is the name of the ion that it came from. And that is the sulfate ion. Okay? Now, this is not 8, this is ite. So it has to have a different ending for the acid name. And it turns out when that happens, it ends in OUS acid. So the name of this acid right here, now, again, this is not a halogen, this is not a group 7A element, so it's coming from group 6A. So when we did the previous acid, when we had sulfur, like we have here, we kept the UR, and then we're going to do that again here. This is sulfurous acid. And we do have a couple of phosphorus acids, H3PO3, H3PO4. The PO4 is the phosphate ion, so H3PO4 is phosphoric acid, like we talked about. And H3PO3 is phosphorus acid, because PO3, 3 negative, is the phosphide ion. And we keep the phosphor part in the name. And that's because the English language is a mutt language and did whatever it needed to do to have a name for these acids. No rules seem to really apply except for maybe the halogens. The last one are the organic acids. Now, again, organic is something that we're going to talk a lot about in Chem 2 if you decide to take that, and I hope you do. But the word organic generally means, in chemistry terms, carbon and hydrogen as a minimum. Doesn't have to have oxygen. If it does have oxygen, it's got to have hydrogen along with it. So there's no system of naming that you have to remember now. If you take Chem 2, you'll learn the naming system. But the two names we use is for this one right here. This is acetic acid. And the thing about acetic acid or any organic acid, the acidic hydrogen comes from the end and not the beginning. The oxyorganic in the binary, the hydrogen's in the front, that's the acidic hydrogen. And we'll talk about what that means later on. And then the organic acids, the hydrogen that is acidic comes off. Now, this is the organic way of writing that. There's, again, a reason for that. The inorganic people that the organic people don't like, because they don't like to follow the rules of the organic stuff. They rewrite it so the hydrogen is in front. But then they combine all the ions together, or all the elements together. So C2H3O2. They don't combine the hydrogens. They emphasize the fact, oh, this is an acid. And as we all know, hydrogens have to begin at the beginning of a compound to be considered an acid. Poo on that, because of the organic people said, no, it's at the end, dork. Stop being a jerk. The other one I want you to remember is HCOOH. This is the simplest of all the organic acids. This is called formic acid. If you've ever been bitten by ants and it hurts, this is the stuff they'll inject into you. Particularly red ants have a lot of it. When you get bitten by an ant, it isn't because they have long fangs that come out of their mouths 20 times the size of their body, then jabs your toe or whatever it is they bite. No, it's because they're injecting an acid into an area that wants to be neutral, and it doesn't like it. So, and again, the inorganic chemistry, this is the acidic hydrogen right here. That's the acidic hydrogen. This is not. However, the inorganic chemists write HCHO2. Say, look, this is an acid because it starts with H. They're so obnoxious. All right, so no rule system here. You just have to know that these are the two compounds you're going to be dealing with. The other two, the binary, begin with H, means it's and only has one other element, means you're going to start with hydro and end with ic acid. And the oxyacids don't begin with hydro. They begin with the name of the polyatomic ion that it came from, and then ends with either ic acid or us acid. All right? Your practice problems. Right here. Give me the names of the following compounds. Have fun!